The term impulse is used to refer to something that is very fast or takes very little time with major consequences. In the context of physics, we have seen that collisions occur for a short duration of time. The force and the duration of time for which it acts both determine the change in momentum of the body under consideration. The combination of the force and the time duration gives the impulse. Impulse is defined as the product of the net force and the contact time, that is, the time duration for which the force acts on a body. Impulse equals vector F net times delta t. We know from Newton's second law that the net force is the rate of change of momentum. Vector F net equals vector delta p over delta t. Therefore, impulse vector F net times delta t is the change in momentum vector delta p. This is referred to as the impulse momentum theorem. Impulse is a vector quantity having the same direction as the change in momentum vector of the body. In cricket, when a batsman hits a shot, the impact of the bat on the ball occurs for a very short duration of time, but the force is large enough to reverse the momentum. When a fielder needs to catch a ball, he needs to bring the momentum of the ball of a given mass and moving at a given velocity to zero in a short interval of time. In this case, the change in momentum, vector delta p, is constant. If he merely tries to stop the ball, it hurts his hands. This is because the time duration is very small, delta t, and the force exerted on his hands is therefore very large. On the other hand, if he moves his hands in the direction of motion of the ball as he takes the catch, he increases the time duration of the collision. The net force is now less, and therefore his hands hurt less.
Starting to feel it? Now go master it.